Hey everyone, it's Mr. Chapa. I wanted to wrap up first I should probably plug in my headset. The interval question from the end of class on November 15th. This was the conclusion of question 9.71 about having an explanatory variable of the approval rating for an incumbent president running for re-election. And the response variable was the margin of victory, negative if they lost. And so we were going to continue by doing the prediction interval, which I challenged you to do at the end of class on Monday. I want to clarify that there's some values that we're still going to use. In fact, all of our values are pretty much the same. And I left the hat off of the Y. So let's draw that real quick. All right. So, but our 95% confidence level still gives us T equals 2.2281. And by the way, if you haven't watched the end of the previous video, if you weren't in class, I highly recommend checking that out before jumping to the conclusion of this question. But we still have a sample size of n equals 50, a given explanatory value of x star equals 50. I'm sorry, sample size was 12, x star equals 50, a given mean value for the approval ratings of 52.92, the standard deviation of the approval ratings of 11.04, the standard deviation of errors is still 5.6604, and our y-hat value is 5.19, which is what's obtained by substituting 50 into the regression equation. The only real difference that we have to do is when we calculate the standard error, it's the standard deviation of errors times the square root of 1 plus 1 over n. The 1 plus is what's different about the formula, but the rest of the formula is still the same. So give me a second to get that set up. All right, so there's the formula for the standard error of a prediction interval. And just as a reminder, the formula for the prediction interval is given to you not in terms of the standard error and all that jazz. It's just given to you as this big clump, which I'm getting to and zooming in as much as possible right here. Let me zoom in once or twice more. It's just that formula where they lump it all together as a gigantic formula for calculating the prediction interval, but it follows the confidence interval protocol in the sense that, why don't you let me draw? Hold on, folks. I don't know if I'm experiencing lag or what. It's just not letting me draw things on this. It should. Got some serious lag going here. Oh, it's because I'm recording a Zoom session while there is a meeting converting. So hopefully I can get past the lag and let me draw on this PDF. There we go. All right, so, but you're still following the same confidence interval building processes. You're still finding a value for T, which has a star in it here. You're still finding a value for the margin of error. And it might be lagging because I'm zoomed in so much. And then when you multiply those together, it still makes your margin of error. And then you add and subtract it to, in this case, y-hat. So it's still following the same confidence interval building procedure. It's just not broken down into little bitty steps like it was when we reviewed confidence interval building for test 1. All right, so anyway, let's close that. And let's go back to the whiteboard. So anyway, if we were to just put all these values in that we have, then we would get 5.6604 times the square root of 1 plus 1 over 12 plus a longer fraction. In the parentheses is 50 minus 52.95. 52.92, excuse me, squared. And in the bottom, the n minus 1 is 12 minus 1. That's just 11. So let's just go ahead and put 11 times Sx, which is 11.04 squared, So all this goes into a calculator and just gives us a different value for the standard error. So give me 1 second to do this. And I'm going to call out what I'm typing in. I'm going to start with the big fraction under the square root. Parentheses 50 minus 52.92 close parentheses squared divided by open parentheses 11 times 11.04 squared close parentheses plus 1 divided by 12 plus 1, press equals to complete that calculation, square root that answer, and now multiply it times 5.6604, and we get a standard error of 5.9088 when we round. Now, just for comparison, when we did the confidence interval that did not have the 1 plus under the square root, we got a smaller standard error of only 1.6952. Our standard error now is all the way up to 5.9088. So you can tell this is going to create a larger margin of error. Our margin of error is going to be the t, which was 2.2281 times the standard error, which was 5.9088. Is that what I wrote on the last one? Yes, 9088. If we multiply those, we get 13.1654. So that's our third step in our confidence interval. Of course, this is our second step. Our first step was to find the t, or prediction interval, I should say. And so our fourth step is to figure out y hat plus or minus the margin of error. Our y hat was 5.19 plus or minus 13.1654. And so now our interval is 5.19 minus the margin of error, which is negative 7.9754, to the sum, which should be 18.3554 if I did it correctly. 3554, if I did it correctly. And so that's our prediction interval. And remember, the main difference between this interval, this prediction interval, and the confidence interval that we got at the end of class last time, I got to find it here. The main difference between that answer and this answer, well, let me highlight that because it's a PDF, but I can circle it. The main difference between that answer and this one is that the objective of the confidence interval is to say, I am 95% confident that the mean of all of the margin of victories is in this interval. The purpose of the prediction interval, this guy, is to say 95% of the actual margins of victories are in this interval. And again, the analogy I used in class is that when you do a confidence interval for the mean, it's like there's a whole bunch of butterflies and you're trying to capture the average butterfly. So you have a small net, but a prediction interval's goal isn't to capture the average butterflies, to capture 95% of the butterflies themselves. Therefore, you need a larger net, and in this case, a larger interval. And this prediction interval says we expect some people with a 50% approval rate to lose their election because their margin of victory might be small.